So today we are going to work on the NumPy Python library. You're able to see the screen?
Yes.
Yes. So if you can open a new notebook and then you can just follow along as we proceed.
Okay.
Yeah. So remember to open a new notebook, you go to New, select Python 3. Then the first instruction we are going to give is this one in line 1. Import NumPy as NP. Basically what we are doing, we are bringing in the library into Jupyter Notebook, and it's the best explanation I can give it is this is like an application. So you have Python as the base, but then you have specialized libraries that have been set up to perform various operations more efficiently than you would with just native Python code. So you type that in and then you run that cell. Then the first thing we're going to tackle is now creating different arrays. And there are different ways you can do that. One of them is just doing it from a Python list already. So like you see up here, I have a list is equals to 1, 2, 3. So to create that into a Python array, between a NumPy array, the following line, a new array is equals to np.array, and then you feed in a list into that argument, and that will result into the new array. And you can do the same thing. The third cell you see, instead of just one list, a simple list, we have a list of lists, which again now using the same command is going to give us a two-dimensional array in NumPy. So you see in line 4, using the type command and feeding in the different structures that we have set up, you can see that the first two show that those are just lists, and the second two show that they are NumPy arrays. Watu wamemaliza, we move on.
No.
Still typing? Giving it another 30 seconds, and then you can move to the next section. Okay, so other than creating from Python list, you can create arrays directly in NumPy. And there are several ways of doing it. So the simplest one is just doing an np.array and then feeding in a list. So you can either feed in a simple list or like a list of lists, which will produce a multi-dimensional array. And you can even have dimensions more than just two. This had better work. Yeah, there you go. Okay. Then there are certain commands that let you generate values automatically. And the first one you're going to look at is arange. So np.arange, you can feed in either a single number, and that's going to produce values up to that certain number. So if I np.arange 20 will produce a list of 20 values evenly separated by 1. And it's going to go from 0 to the number you have specified less 1.
Why did you specify?
Pardon?
Why did you specify the array you wanted to display?
In which one? In this cell 8?
Yes, yes.
I just put in the number to that arrange function, and it automatically is going to generate the array and display it for me. But if you want to save it as a variable, then you have to explicitly do that.
You're auto-generating an array.
Using the arange, yes. You just feed in the parameter of how many values you want, and it's going to now generate automatically for you. So if we call it, then now we have the result of that operation.
Okay, that's clear.
Mm-hmm. So you can either feed in the single value, or you can feed in a particular range. In this case, we've said from 0 to 10, but you can also do range from any number to any number, 35. And it's going to produce the array of the range that you have specified. And remember, it's from the beginning to 1 less than the last number. And like the following cell shows, you can define the steps to skip. So in this case, from 0 to 11, but we are skipping every other value. And so we just get now 0, 2, 4, 6, 8, 10. Okay, moving on to the next one. The next command we can use is linspace. So np.linspace. And what this one does, that you give it two values. The first minimum is the first and the second. And it's going to generate an array of evenly spaced values between those two. The only difference between linspace and arrange is that for linspace, it includes the last value. So in this case, you can see it goes from 1 to 10. And instead of separating it by an evenly integer value, it's going to get values between those two and have the same interval between them. So in this case, from 1 to 10, there's 4.5 between 1 and 5.5, and 4.5 between 5.5 and 10. So that's what it does. And if we specify 3 values, so that you're going to get 1, 5.5, and 10. But you can see in the next one, from 1 to 10, we have specified 10 values. And so it's going to have 1 between each of the 10 values that we have asked it to give us. Without an argument, it's going to return 50 values. So in this case, from 1 to, without the third argument. In this case, between 1 and 10, it has given us these 50 values of evenly spaced digits. And you can see that if I was to specify a value of 50, it's going to give me the exact same thing. And to test whether that is true, you remember last week we did conditionals. So I just tested for X to see if it was equals to Y, and you can see everything it returns in that array is true.
So, sorry, Eric, could you just explain again that?
For the linspace?
Yes.
So linspace, unlike arrange, does not return values that are spaced by integers. Arrange, you noticed that the arrays, the interval is are differentiated by integers. So like in this case in cell 11, the difference between each value is 1. For linspace, the value is not necessarily an integer. For this first one, you can see that in the first, between 1 and 5.5, the difference is 4.5. In the third one, yes, the interval is 1, is an integer, but that's because we have set it up to do it that way. If I was to change the third value to 9, you can see that we are going to get 9 values, each of them separated by a float value and not by an integer value. So that's the difference between linspace and arrange. Answered your question?
Yes, and the numbers are random, right?
For linspace?
Yes.
No, they're not random. Because if I was to run this again, each time it will give me the exact same set of values. This does not produce random values, it just produces evenly spaced numbers by a definite interval. Random will come to that later. Any other questions? Can move to the next one. We have a number of commands that we can use to generate specialized matrices. The first one is I, which produces an identity matrix. So you just feed in the number of values you want, the dimensions that you want. So in this case, NP I5 is going to produce a 5 by 5 identity matrix. Which you can also do by doing identity 5 and running that. Both commands will give you the same identity matrix. Then we also have zeros and ones, and both of them will generate arrays of either all zeros or all ones. So if you give it just a single digit, it's going to give you a vector of the number of zeros that you have specified. But if you give it two values, then it's going to give you that dimension of arrays with the numbers that you have specified. So in this case, NP0 is 5 or 5 by 2, and NP1s or NP1s 2 by 5. Then one thing to note for generating the two-dimensional arrays, either of the ones or the zeros, is that you have to pass in a tuple, which shows the dimensions that you want the array to be. If I did not, if I had set in just the two numbers on its own, this will generate an error because it does not understand what you're trying to put in. So make sure if you're generating a two-dimensional array from this, that you pass in a tuple. Okay, now we can go to the random values. So the first one we are going to look at is rand. So rand, you can put in a single value in there, and it's going to generate the number of random values that you have specified in there. And these are going to be values between 0 and 1, exclusive. So if I was to run this command, each time I run it, it's going to produce different values. And then again, for the second one, a multi-dimensional array. I can put in 2 values, and again, same thing, it will produce a value of those dimensions of random values. And same thing, every time you run it, you get different values.
So always the values are between 0 and 1.
Yes, between 0 and 1.
So Eric, what does the rand mean?
Pardon?
What does the rand mean? Dot rand.
Dot rand is the one that generates a uniformly distributed set of values between 0 and 1. The next command, rand n, is the same, just that instead of a uniform distribution, it's going to generate a normal standard distribution of values. So rand n, those are methods of random. Random is the main function that generates the values, but then you can specify what kind of random values you want, whether it is uniformly distributed, standard normal distribution, and the next one below that one, a random integer. So for random, and like I said, it's for normal standard distribution, and the same thing. If you just give it one value in here, it's going to return a vector of those number of random values. So if I change this to 4, it'll give me 4 values. And then for random, for the normally distributed, it's not bound between 0 and 1. It goes from -1, it goes from a negative infinity to positive infinity. And then for integers, we have the rand int. So it can generate any number of random integers. If you just set in the start and the final, it's going to give you one value. And it's from the lower limit to the upper limit -1. So you'll never get 100. It's going to be from 1 to 99, any number from 1 to 99. But if you want more than just one value, then now you specify the third parameter in that argument. Any questions so far?
So if I wanted to generate an array with people's weights, ranging between 40 kilograms and 110 kilos. So say 50 people. How do we do that?
Is it values that you already have, or you just
random.
want to randomly generate it?
Random.
Randomly generate it?
Yes.
If it's integers, you definitely use rand int. Then it's from 52.
Say I want to generate weights of 50 people between 40 kgs and 150 kgs.
And 150 kgs.
And it should be not just integers, sorry.
Mm-hmm. So what is you asking?
So I wanted to have 50 people of weight between 40 and 150.
Mm-hmm.
Should allow me to put
Floats.
floats.
Okay. So the other thing that I should have mentioned right from the very beginning is that you're not supposed to memorize all the things that you're talking about, but you have to have an awareness of them. So in this case, I don't have an answer to your question, but now that's where research comes in. So if we go, we can look for that. We can go to the NumPy documentation. Let me just. So one good source of answers in case you get stumped with a problem is Stack Overflow. Stack Overflow. In this case, we have searched for that, and we can now look at the first C and see what it has to tell us about the problem we have, and see if we can answer Moses' question. So we can see here we have random, uniform, low is 0.5, high is 13.3, size is maybe 50 values. So we can try that command and see if it's going to give us the result that we want. So we change this. You said 150. Oh, sorry. So there you go. Your 50 values of weights from 40 to 150.
But let me ask, what if you don't want it to have too many decimal points? Like, see the way when it comes to weight, we'd say like 40.5 kgs, because here it has very many decimal points.
Okay, so we go back to our research and find out how to format the output. Let me see. I don't have an answer right now, but I'm going through the docs later, and then once I get it, I'll let you know.
Okay, that's fine.
But then you can also on your own research and find out, and if you find the answer before I have it, you can share it to the group.
Okay.
Yeah, thank you for that question. Okay, so we can move on. Yes.
So what if you want the weights to be in a normal distribution, like because I can see they are appearing in a uniform distribution.
So that won't work. We can come to NumPy and find out what the different random values are. Again, we can look through the documentation and find that out as well. So another exercise for both myself and you people, we can research on that and find out. So Harriet, you're looking at the decimal places. Ernest, you're looking at whether you can have different types of distributions, and we can report back to the class.
Yeah.
Sawa. Any other question? So now we go to array methods. Array methods enable us to manipulate arrays in different ways. And one of the most common ones that you're going to use is the reshape method, which reshapes an array to a different dimension than the one that you initially specified when you initialed the array. So in this first one, we have an array of 30 values, and we've generated that using arange. So we can reshape that into a two-dimensional array, either 5 by 6 array, which is the next example, or a 10 by 3 array. The only thing you need to note when using the reshape command is that the number of values returned has to be equal to the value that you initially identified. So in this case, we have 30 values in the array. And so if I'm reshaping it into a 5 by 6 array, 5 times 6 is 30. So it's going to give me back 30 values. But if I was to use factors that either produce less or more, in this case, you can see in cell 28, I have 3 by 9. That's 27 values, and that is going to give me an error, because the number of values is not commensurate with the size of the array that we are trying to reshape. Then if you're reshaping an array, what you need to do if you want to keep the newly shaped arrays that you have to assign that to a variable. As you can see in cell 29, if I run that, then the array is still going to be the same one-dimensional array of 30 values. But if I reassign that to a certain variable, then the new variable will keep the reshaped array. Then the other methods that we have are min max, argmax, and argmin. So these give you the minimum values or the maximum values in an array. The first two commands, the min and max. The argmax and argmin give you the position of either the maximum value or minimum value in an array. And then a note on the random array. So if I've assigned this to a variable, random r, and each time I run this cell, you'll notice that the values change. But if I don't want to have those change all the time, then I can just assign that once. Sorry about that. Each time I call the variable, then the variable is going to be the same. So that's something you need to watch out for. If you're generating a random array to use, assigned to a variable to use in your computation, but you don't want that to keep changing, make sure that you don't call that variable in the same cell where you assign the array. Yeah, so random R max will give us the maximum value, which is 48 in that one. And it is in position 5. Minimum is 3 and it is in position 7. And since we have 2 of them, it's going to take the first one that it finds. Any questions so far?
Could you repeat the argument max and argument min
So
explanation?
argument max and argument min provide the position of either the maximum value or the minimum value of in an array. So let me just create a simple array. So if I do array.arg max, it's going to give me that in position 3, which is value 1, is where we have the minimum value. I'm sorry, is position 8, we have the maximum value. And if I was to do argmin, that's going to be position 2. So array.argmin, position 2. So it gives you the position of either the maximum value or minimum value in an array. So if you were to go back to the list we generated of weights. Yes, I use weight array. So in the weight array, the maximum value is in position 12. And we use the min method to tell us what that value is. Sorry, max. So that's the 148.8 kilos. And Likewise for the minimum values. It's in position 10. Which mean is 40.7 kilos. Clear?
Yeah.
Okay. Then from methods, we're going to go to array attributes. So the first one is dimensions, which gives us the dimension of an array. If it's just a single vector, then it's going to give you a dimension of 1. If it's an array of several dimensions, it's going to give you the number of dimensions of that array. And the argument is array.ndim, number of dimensions.
How did you create the weight array?
The weight array.
Yeah.
Oh, that was in an answer to a previous question. The question was how to generate an array of 50 values between a certain range and a second range. So basically, you just using this command np.random.uniform, which will generate a uniformly distributed set of values, and you specify the lower limit and the higher limit and the number of values that you want. If we change that to 500, you get 500 values between 40 and 150. Likewise, if we reduce to 5, you only get 5 values. Any other question? Okay, so dimensions. Then the other attribute you can look at is a shape. So shape, the first one will return just one value, which shows that it's a vector. And we are using these arrays that we had specified back up here. And for the reshaped array, it's a 2-dimensional array. And so it's going to give you that the shape is 2 dimensions, which in this case is 4 by 5. And then the third attribute that you can explore with arrays is the type of values that are in the array. So you can either have integers. The first one will return an data type of int64. So these are 64-bit integers. And the second one, because we have already specified the weight array, we can even just use that one. And if we run this, no, sorry, here we are specifying the array. And so we don't have to. But it was to look for the type of the weight array that we generated. It's going to give me the same result of float64. So weight array dot b type. Same thing, float64. And just as a point of note, we are just doing a survey of the different things in NumPy. There's a lot more to it than just what we have shown here. And so you're encouraged to go to the documentation and just read through and see what all the attributes are, what the different methods are, the different ways of generating arrays that we may not have covered in this class. This is just a survey. Any questions so far? So now we go to indexing and selection of values in an array. So we've generated our array of 10 values, sort of 11 values using a range. So the selection is similar to what we saw in lists in Python. So you just use the bracket notation to select what you want out of the array. In this case, we want value in index 8, which in our list, in our array, is number 8. If you want from the beginning to a certain index value, it's the same thing as in Python. So you leave out the initial colon, and then you have specify the final value. And likewise, from a certain value to the end, you specify the starting value, colon, you leave out the final value. So this is just revision so far. To select a range of values separated by a certain interval, same thing. So you specify the first, the final, and the number you want to skip. You can also specify using negative indices. When doing negative indices, it starts counting from the right. So the value 10 in our array is going to be index -1, 9 will be -2, and it's going to go all the way to -11, which is going to be 0. So to reverse the array, you specify from the highest value 11 to 0, and then the step of -1, and that's going to reverse. And using negative indices, the following cell shows that. So where there's a difference between NumPy and Python lists is that for NumPy, you can select a range, you can add in a list of values to specify what you want returned from that list. In NumPy, you cannot do that. So we have this list of values, but I want values in position 0, 4, and 7. If I was to run this command, I would get an error because the Python list would not allow me to do that. If we convert that Python list into an array using the np.array command, and then I was to rerun that command, it will return those values. So in this case, I have 10, which is in position 0, 54, which is in position 4, and 7, which is in position 7. That's one advantage that NumPy has over Python, over the Python list. And one use of this will be, let me see. So you see, a good thing about that is that you can use that to change values in the list. Since you just select the index positions where you want to change those specific values, but leave the rest of the values unchanged. Which leads us to broadcasting. And broadcasting is a way of changing a certain number of values in the array, which you cannot do in a Python list. So here you see I've created the Python list and I want to change the values up until position 6 to 33. But if I try to run that command, it will not allow me to do so. So changing that same list into a NumPy array and rerunning the command allows me to do that. As you're changing these values, something to watch out for is when you try to assign an array to a different variable so as to create a copy, that is going to run into problems as shown in these next cells. So we've specified our array. We've done our slice and just selected a certain number of arrays. So we've created a new variable from a slice of the original array, which is values from index position 0 to 6. And then we want to change those values to 55. But if I run the original array, you'll notice that the values have also changed from 0 to 6. And the reason this happens is that if you use the assignment variable to create a copy, that copy and the original point to the same locations in memory, just that they've been called by different names. So when you change one, automatically the second one also changes to those positions in memory that you've done the operation. So if you want to create a copy that will not affect the original, then you have to explicitly use the copy command. So here we have our array, we have reset it again from 0 to 10. So to create a copy, then you have to create this copy command. So it's going to, the copy array is going to be the original array dot copy. Now, if we repeat our commands from above, so we create our slice from 0 to 6, and then we fill in those values with 55. So array copy has the changed values, but our original array is unchanged. So that's something to watch out for.
Is that only for arrays or even for other variables?
For NumPy, it's for arrays. If we were to, can experiment just now. So x is equals to 3, y equals to x, y. So let's call both x and 3, x, y, 3, 3. But if we were to change, and then you call again the two values. Yeah, it's just for arrays. Regular variables, that doesn't affect it.
Okay.
Any other question? Okay, now we go to indexing 2D arrays. So basically you can either do, as shown up here, array, bracket row, bracket column, or you can do array bracket row, comma column. The second one is recommended because it's easier to remember. If I was to run the two commands, it will give me the exact same value. If I want to get a row, then I just specify one value in the bracket command. If I want several rows, bracket initial value colon final value. And remember, it's final value less one. So in this case, it's going to get me index 2, 3, 4, rows 2, 3, and 4. Then if I want to index a column, again, same command, just that it's going to be colon, comma, and then the column that I want. In this case, I want column 3. If I'm getting just one column, it's going to return it as a row. But if I get the same command, but now I want several columns, then it's going to return them as columns. Then again, you can combine both of them to select just a portion of your array. So in this case, I want rows 2, 3, and 4, and columns 2, 3, and 4, just the values in that section. It was to call out the full array before this. So I want values 14, 15, 16, 20, 21, 22, 26, 27, 28. And for that, I use this command. So it's going to get these 3 rows and only these 3 values in those specified columns. And the good thing about NumPy is that you can also select rows and columns out of order. You just pass in a list of the rows that you want. Call array again. So like in this command in cell 128, so I want rows 5, 1, 4, and 0. And you can see the first one, 30, 31, 32 in the above is row 5. Row 1 comes second, and on and on. And the same thing for column. You can call columns out of order depending on your needs. So here is a challenge for you. Based on what we've done so far, make a screenshot of this image and the second one. Once you've gotten this one, let me know so I can have you take the next one. Gotten this one?
Not yet.
Okay. Okay. So that one, and then this one. So get a screenshot of this as well. Or alternatively, I can just send them the two images on WhatsApp. So what I want you to do, based on everything that we have done so far, so generate this array. All the material that we have covered so far will enable you to generate this array without having to type in the numbers individually. And then I want you to make these selections. So the first selection will be the values in the square in blue. Second command should return these values in the squares in green. And the third command should return the values in these squares in red. So I'll share these images on WhatsApp, and just come up with a notebook that has the commands that generates these two arrays, the first array and these selections from this second array. Then you can share with the rest of us what your solutions are. That is homework. So now we go to comparison operators based selection. We generate our array. Then if we ask it to give us a result of whether the values in the array are greater than 4, we use this command. And what we're going to get in return is an array that shows us whether it's true or false for our operation. In this case, we see that the first 4 values, for the first 4 values, the result is false. For the remaining values, the result is true. We can assign that operation to a variable. And the beauty about this is that if we now feed in that variable into our array, it's going to return only the values that are true. In this case, 5, 6 to 10 are greater than 4. And so the array that is returned is only going to have the values that correspond to whatever test that you are trying to do. So you can either feed in that variable, or you can explicitly feed in the state method, or you can assign the value to a variable and then use again, if array is greater than X, it's going to return only the values that correspond to true for that statement. Any questions so far? And this can be as complex as you want. If we go back to our weight array, and okay, what did I do wrong? So it returns the values in the array that only correspond to weight being greater than 50 and weight being less than 120.
Is it that NumPy does not recognize and written in full?
No, the and written in full. Here I'm trying to make a logical comparison. But the and ampersand is the one that now, that's the operator. It shows that I want you to return value of this first one and this value of the second one. But if I was to do and, as you say, it results in error, and just returns a true or false.
Oh, okay.
So even for or, I wouldn't use or. I would have to use I will have to use this command. Sorry. Same thing.
Okay.
Any other question?
No, I'm good.
Okay. So arithmetic operations. This is where NumPy is head over shoulders above NumPy Python lists completely. You can do so much more operations in arithmetic with NumPy arrays that you cannot do with Python lists. So here we generate our list in Python, and we convert that same list into an array in NumPy. So remember, in Python, we tried to double to get double the values of the list, of the items in the list. But if you do num times 2, all it does is just doubles the actual list itself. And to get the values doubled, we had to use a for loop. But for NumPy arrays, I can just do the array times 2, and it immediately brings the results. Same thing if we did the addition, but for arrays, just doubles the results. Other operations like multiplication, the list will not allow you to do that. But NumPy arrays will let you do that. And what it does does item by item. So it's going to get item 1 times item 1, go to the next one, items 2 times items 2. Again, same thing for division. Basically all arithmetic operations, it's much, much more convenient to do it using NumPy arrays than Python lists. Because Python lists you would have to generate, to use a function or a for loop or something to do the same operations that requires just one line of code with a NumPy array. One thing to watch out for with NumPy arrays is what you get when you do division by 0. Typically, if you were to do divide by 0, divide by 0 will result in a division by 0 error. But if you have values in a NumPy array, it's not going to result in an error. It's actually going to get you an answer. So if it's any number divided by 0, then you're going to get infinity. You'll have infinity returned. If it's a 0 divided by 0, you're going to get not a number. And so it's not going to throw an error, but it's going to give you a value. So that's something to watch out for in your computations. Okay, then finally for NumPy arrays, there's the universal array functions, different mathematical functions that you can work on using NumPy. So the square root, you can get the exponent. For trigonometric functions, you can get the sine, you can get the log. And all these are specified in the documentation, which I've linked to. So you can see all the different functions that you can work with the NumPy arrays. Again, I recommend just going through this and create arrays and experiment away. Any questions of everything we've covered today? So this was what we were to have done today, but since we have a little more time, if people don't mind, probably can do a very quick introduction of pandas and then take it up more in detail next week. Is that okay?
How can we get these notes?
I'm going to share this.
Okay.
Yes, I'll share this.
Eric,
Yes.
can we do the pandas next week?
So, not a problem.
Some of
Too much
us
to
need
take in.
to swallow the NumPy first. Yeah,
Sawa.
please, kind.
Not a problem.
What are the
Okay.
equivalents of NumPy
The equivalent in what way?
in terms of the alternatives, or it's just
Well, NumPy, it's part of a bigger set of libraries called SciPy, Scientific Python. So NumPy was set up more for mathematical linear algebra type operations. And it's pretty much the basis of pandas. Everything, a lot of the data science analytics tools in Python are based on NumPy. It's like the chassis upon which everything else is built. So I don't think you could get like an alternative at its level.
Okay.
But above its level, of course, there's pandas, which is the one that is most widely used in data analysis. And even for at the level of pandas, I don't think there's an alternative that comes close. But now when you go beyond that into plotting libraries, there's Matplotlib, which I think was the first one to be developed. But now you have other plotting libraries like Seaborn, Plotly. So at its level, I don't think you can get an alternative that is as versatile as NumPy.
Okay.
Mm. Okay.
That's fine.
I guess if there are no other questions, we can call it a meeting. The two things, so Harriet, you're researching for us the decimal points. Ernest, you're researching for us whether you can get other distributions. For everybody, I've shared the two images on WhatsApp. So the homework, which hopefully we can get before next week's lesson, is your code solutions on how to execute those arrays and those selections. I'll also share these notes and also a link to the NumPy documentation, which I highly recommend you read through. And I think also one other thing you can do is find a command that we have not covered in class and read on it, come up with examples and share with the rest of us what you find out about it and what operations you can do with it.
So next week we'll cover pandas alone?
Yes, from next week we now get into pandas and now move on from that, now get into data analysis. And for that, we're going to use the Kenya census data. So we've gotten a number of the tables converted into CSVs. So we'll share those with you as well, because that's now what you're going to work on exclusively for the rest of the course. So looking at it, reading it in, cleaning it, analyzing it, all that stuff.
Okay.